All right, so this is the lesson that follows the log function lesson, and so it shouldn't surprise us at all that in this lesson we talk about exponential functions, and it shouldn't surprise us at all. Oh, sorry, shouldn't surprise us at all because they naturally follow log functions. So let's take a look. Let's see how this all goes. From our last lesson, you remember the log function. This is the natural log function. It passes through 1, 0. It passes through E1. Those are the two real key points that you need to have handy. What the exponential function is the inverse of the log function. And this is something that should be familiar to you from your time in Algebra 2. This is the line y equals x. It is a symmetry line between the natural log function and the exponential function. Because the log function passes through 1, 0, and E1, the exponential function passes through 0, 1, and 1e. Because the log function is concave down, its inverse is concave up. Because the log function is increasing, its inverse is increasing. These are all things that are true because the two functions are inverses. And because the two functions are inverses, they sort of undo each other. It is true to say that e to the natural log x is x, and it is true to say that the natural log of e to the x is x, provided that x is a positive number, because we can't take the log of a non-positive number. So this is the stuff that's familiar to you from Algebra 2, and all of those things are still true here in Calculus 2. So just a little bit of algebra. This is a little bit of algebra, nothing fancy here. How do we solve this thing? Well, we're trying to get this to come down from being so high, and so we take the natural log on both sides. And the natural log of e to the thing, right? This is what we were just talking about. The natural log of e to the thing is just the thing, because the natural log of e to the, oh, this is terrible. The natural log of e to the chicken nugget is in fact chicken nugget. And that's the key piece to take away from this question. So x turns out to be the natural log of 6 minus 1 over 3. My warning here is this is not the natural log of 5 over 3, but that's one of the more common things that folks try to do with this 6 minus 1 deal. Okay. Staying with algebra for a moment. Let's stay with algebra for a moment. What does it mean to say e to the negative x? Well, e to the negative x is e to the x, but upside down. So then what do you do with that? Well, you multiply everybody through by e to the x. And then what do you do? Well, this sort of looks like it's a quadratic, and in fact it is. It's a quadratic where instead of an x squared, you've got an e to the x squared. And so this factors exactly the way you'd imagine that it factors. And so you end up with two answers. In this left side, e to the x is equal to 2. And that means that x is the natural log of 2. And over here, e to the x is 1, and so x is 0. So you should be skilled with algebra, and this is all stuff that Algebra 2 would have taught you in theory. all the rules of exponents apply. All the things that you learned in Algebra 2, e to the a times e to the b, add the exponents. E to the m over e to the n, subtract the exponents. E to a minus power, well, that's just the positive power in the denominator. E to a power, to a power. Multiply the powers. These are all things that you learned in Algebra 2, and they are all still relevant. And if you have a to the x, where a is some number, it's not e, it's some number, you can turn it into an e to the something by making the exponent x times ln of a. I'm going to let you think about why these two things are precisely the same. These two rules are precisely the same. This is an application of that one. But I'll let you think about why that may be true. So what is E? Well, is E? By definition, it's a limit as x approaches infinity of 1 plus 1 over x to the x. If you were in high school, they may have done something with compound interest where you made the interest rate compound more and more frequently, but then it compounds more and more times, and that whole thing settles down, and it settles down right around E. It is also the limit as x approaches 0 of 1 plus x to the 1 over x. You don't have to know that for recall purposes. You do have to know that E comes from somewhere. And in fact, we can prove that this is true. We can prove that this is true. And the proof goes off of the fact that the derivative of the natural log function is 1 over x, which is why this lesson has to follow the natural log lesson, because we need the derivative of the log function to do this. How do you take the derivative of this? Well, very early on in Calc 1, you learned the definition of derivative. You learned that that's the limit as h approaches 0 of f of x plus h minus f of x over h. You learned that long time ago. We learned last time we gathered that this natural log of 1, that's 0. So this is the limit as h approaches 0 of 1 over h times the natural log of 1 plus h. And we learned in our last lesson that this thing in front is really a power right? It's really a power. And so this limit is 1, because this limit is the derivative, and that's 1 over x. And 1 over x, that's 1 at 1. So if the natural log goes to 1, then the thing itself has to go to E. The proof of it, that's the reason it works. So, time for a little bit of calculus. It is true that the natural log of e to the x is x. That is true. And since that is true, the derivatives on both sides have to be equal. So the derivative of the natural log of e to the x has to be the derivative of x. Well, the derivative of x is 1. The derivative of the natural log of something is 1 over something times the derivative of that something. Well, what does that mean? That means that the derivative of e to the x is e to the x, just right over there. The exponential function is the only non-trivial function whose derivative is itself. The derivative of the exponential function is the exponential function. The derivative of e to the x is e to the x. So let's play everybody's favorite game. Find the derivative. The derivative of e to the cosine x, the derivative of e to the x times x to the e. So the derivative of e to the cosine x, how do we do that? Well, the derivative of e to the something is e to the something. Chain rule says multiply by the derivative. Over here, we've got a product. So we use the product rule. The derivative of the product first times derivative second plus second times derivative first. Derivative of x to the e, what is that? Well, this is x to a number. So the derivative of x to a number comes down in front. Decrease the power by 1. And that's the derivative you're thinking about. All right, well, that's our 12 minutes and change, and we'll talk about the rest of it when we gather.